Today, we will talk about how can we simplify radical expressions. Now, the main idea that I want you to keep thinking on along the video is that if we want to simplify radicals, we are going to try and write expressions in terms of what it's called like perfect square numbers. Now, what are some perfect square numbers? 4, 9, 25, 36. Perfect square numbers are numbers that you can take the square root of. The square root of 4 is 2. The square root of 9 is 3. The square root of 25 is 5. Square root of 36 is 6, and so on. Those are examples of perfect square numbers. So along this lesson, think of ways of how we can rewrite numbers using perfect square numbers. So now let's see some examples now. Now this is our task. We want to simplify the following radical expressions. Now, the first thing that you should do whenever we're talking about radical expressions and simplification, try to separate what you have inside the square root. So notice that here we have 125 times n. So a square root of 125 times n, you can rewrite that as the square root of 125 times the square root of n. Now, why do we decide to write into this form? It's because we are going to try and simplify every single square root. So let's concentrate here. The square root of 125. Just like the main idea said, let's try to rewrite 125 using perfect square numbers. So now notice that 125, you can rewrite that as 25 times 5. Let's double check that. 125, oops, I'm sorry, 25 times 5. So notice that 125, I can rewrite as 25 times 5. So if we come back to our problem, instead of writing square root of 125, we can just write this as the square root of 25 times 5. Now let's see, can we rewrite the second square root? No, we can't, because there's nothing to simplify, so we just rewrite it. So notice here, this is why we decided to write it in terms of square roots, because we know the square root of 25, and because we know the square root of 25, we can bring it out as just the square root, which in this case is 5. So we can rewrite this as 5 square root of 5, the square root of n. Notice that all we did, since we know the square root of 25, we can just bring it outside as the square of it. So that's how we get this 5. And now, notice that when we multiply in square roots, we can just multiply the insides. So our final answer is 5 square root of 5n. Let's try another example here. Let's look at example B. Now, example B, again, try to separate the squares. So here, instead of writing the square root of 100 times b squared, we can just rewrite this as the square root of 100 times the square root of b to the second. So now, let's see, can we simplify any of the square roots? Well, notice that we know that the square root of 100 is just 10, so that's easy. Times, but now let's see, what is the square root of b to the second? Now, one thing to keep in mind is that when we're talking about square roots, there's always an imaginary 2 there. If you write a square root and you don't write anything in there, there's always an imaginary 2. Now, how do you take the square roots of variables that have exponents? Well, you're going to rewrite the expression that is on the inside, and you're going to divide it by the root, which in this case, the number that we were taking the square root of, which is just 2 in this case. So again, here we can rewrite b to the second, the square root of b to the second, we can rewrite as b to the second and divide the exponent by what we have here on the root. So now this just becomes 10 times 2 divided by 2, so that's 1. So, and this is just 10b. So now, let's look at example C here. In example C, again, the first thing that you should try to do is try to rewrite the inside. So let's just separate that. So we're going to take the square root of 216 times the square root of k to the fourth. So now let's see, can we rewrite 216 as a perfect square? So notice that 216, 216, we can rewrite this as 36 times 6. Well, let's just double check that. 36 times 6, 216. So we're okay. So now we come back to our problem, and instead of writing 216, we're going to write the square root of 36 times 6 times, and again, here, when you take in the square root of some exponent, all we got to do is just rewrite the inside, and we're going to divide it by the root. But again, if you take the square root and there's no number here, there's always an imaginary 2. So that's why we're going to divide it by 2 here. So now, let's see if we can simplify that. We know that the square root of 36 is 6. So this 36, we can bring it out as just 6. So now this becomes 6 square root of 6 times k 4 divided by 2 is just 2. And let's just rewrite this a little bit nicer. So that's 6k squared square root of 6. So now, let's try to look at more challenging problems. Notice here, in example A. So now we have 3 items that are being multiplied. We got the 75, we got the x squared, and we got the y. So again, your first task is just separate the square roots. The square root of 75 times the square root of 2 times the square root of y. Now here's our task. Can we rewrite 75 as a perfect square? Well, notice that 75 is nothing more than 25 times 3. Well, let's double check that. 25 times 3 gives me 75. Excellent. So we can rewrite this 75. We can rewrite that as the square root of 25 times 3. So we're done with the first square root. Now let's take care of the second square root. So notice here, multiplication. Again, if you see nothing on the square root here, there's always an imaginary 2 there. So how can we simplify the second square root? You're going to rewrite the inside, and you're going to divide by the root, which in this case is 2. So that's how we simplify the second one. So that's excellent. Now, the square root of y, it remains as the square root of y because there's really nothing you can do about it. Excellent. So now, we can try to simplify this 25. You can bring it outside as a 5. So now, the first square root, it becomes 5 square root of 3 times 2 divided by 2, so that's 1, so that becomes just x times the square root of y. So in theory, this is your final answer, but we gotta simplify this a little bit further. Now again, when you're multiplying, you can just multiply the square roots with the square roots and the coefficients with the coefficients. So now this becomes the 5 in the x stays outside because they're outside of the square root. And now those which are inside the square root, you multiply them. So 3 times y is just 3y. Let's look at example B now. Let's take it one problem at a time. So let's see. Again, all you gotta do first is just separate them. So we got the square root of 36 times the square root of x to the second times the square root of y to the third. Excellent. So now let's try to simplify each square root individually. So the square root of 36, this is just 6, times, notice again that there's an imaginary 2 there. So if we want to simplify this, it becomes x 2 divided by 2 times, again here, there's always an imaginary 2 there. So the third square root, it becomes y to the third divided by 2. So now let's see, can we simplify anything? Well, 6 remains 6, x 2 divided by 2, so that becomes x. Y, can you simplify this fraction? No, you can't, so leave it as y 3 to the second. Let's look at example C, and then we'll finish it up with D. Now here, example C, again, what you gotta do first is just separate it. Notice that in C it's a little bit different because we have a number outside, so you will see how that plays a role in a second. So since we have a negative 3 outside, just leave it outside, and you multiply by the square root of the first thing, which is 24, times the square root of 8 to the fourth, times the square root of the second expression, which is inside, b to the second, times the square root of c to the third. Excellent. So now we start thinking, well, how can we rewrite 24? So notice that 24, we can rewrite that. So the negative 3 stays outside. Let's just put that in big parentheses, because that's going to affect everything. Let's just rewrite this, because the negative 3 was outside. Let's just rewrite it as a big parenthesis. So now let's see, 24, we can rewrite that as 4 times 6. Now 8 to the fourth, if we take the square root of it, that's going to become 8 to the fourth divided by 2, because again, there's an imaginary 2 here, times b to the second, take the square root of it, there's an imaginary 2, so now this becomes b2 divided by 2, times c to the third, take the square root of it, so that's the same as c 3 halves. So now notice that here, this 4, we can take out the 2, so now this becomes negative 3, parenthesis, now we have 2, square root of 6, a, 4 divided by 2, so that's 2, 2 divided by 2, well that's just regular b, and c 3 halves. So now this is where the negative 3 comes in handy. You can just multiply to the first. So now this becomes negative 6, square root of 6, a to the second, b, c 3 halves. And just to make it nicer, we can rewrite everything as everything that is on the outside of the square root is being multiplied. Negative 6, we multiply by a to the second, times b, times c 3 halves. So we can put them all in front of the square root. A to the second, b, c 3 halves, square root of 6. So let's just take a look. Last example here, example D. Again, if there's a number outside, write as a big parenthesis. And now let's try to rewrite everything inside now. Square root of 8 times the square root of p to the second times the square root of q to the third times the square root of r. So now let's see, how can we rewrite this 8? So notice that 8 we can rewrite as 4 times 2. So now this becomes the square root of 4 times 2 times p. Again, remember there's always an imaginary 2 there. So let's just place it there. So now this becomes p 2, and we gotta divide it by the root, which in this case is 2, times, now let's take care of the next square root, q to the third, divided by the root, which in this case the root is 2, times r. Now notice that here, if we r, there's always an imaginary 1 there. So now it becomes 1 divided by 2. Close the parentheses, and now we see, well, notice that this in this first square root, the 4, you can take it out as a 2. So let's just finish our problem here. So now the 2 still remains outside. This 4 can go out. So now this becomes 2 square root of 2 times p 2 divided by 2, so that's 1. Q, you cannot simplify 3 halves, so remains as 3 halves. R 1 half. Excellent. So now here, you can distribute this 2. Notice that everything has been multiplied by, so it's only sufficient for you to multiply this 2 with just 1. So now this becomes 4 square root of 2 times p times q 3 halves times r 1 half. So we can just put everything that has been multiplied in front of the square root. So now this becomes 4 p q 3 halves r 1 half square root of 2. Now, in the next slide, here's your entrance ticket. Just try to simplify the following 2 examples here.